Today we'll be working on the following problem. Let X and Z be metric spaces, Y be a compact metric space. Let mapping F from X to Y and G from Y to Z. Suppose that G is injective and both G and G composite F are continuous. So we want to show that F must be continuous. Pause the video if you want to work on this problem by yourself. Okay, let's see. We have X, Y, Z. They are all metric space, and Y is a compact metric space. And we have a mapping. This is F from X to Y and G from Y to Z. So this is the composite mapping G composite F from X to Z, right? So now we use D sub X is the matrix defined on X, and then D sub Y is the matrix defined on Y, and the DZ is the matrix defined on Z. All right, so now in order to prove like F is continuous, what do we have to show? So we are going to use the characterization of continuity in terms of sequences, right? That is to see F is continuous at X sub 0 in X, if and only if for any sequence X sub n in X, if we have the matrix of X sub n, X sub 0 goes to 0 as n goes to infinity, we have the matrix in Y, F of X sub n, F of X sub 0. This also goes to 0 as n goes to infinity, right? This is so if and only if. So now we want to prove like F must be continuous. Basically from here you can see if Y injective and continuous and the composite is continuous, then this F must be continuous over here, right? So so now we say, so now suppose suppose we have a sequence X sub n in X, and now the X of X sub n goes to 0 as n goes to infinity, right? But suppose F is not continuous. So we prove F is by contradiction, right? So now we suppose we have this sequence, but F is not continuous. Then we have what from this criteria, right? And then the limit and property of limit. Then there exists some epsilon greater than 0, and subsequence we denoted by X n comma I. This subsequence of X sub n, this sequence such that the matrix in Y space, right? F of X n comma I and F of X sub 0. This always greater than or equal to epsilon 0 for all I, right? The subsequence. So let's say this. So now we want to draw a contradiction if we assume this, right? So from here, since now by assumption, G composite F is continuous. So we apply this to this x sub x the sequence x sub n comma I, right? Because this is also goes to x sub 0 in x, but now this in continuous. So we have this now G composite F is mapping to Z. So this G F applied to this sub sequence. This goes to 0, right? Because it's continuous. Now this goes to 0. We have, now if we look at this sequence, now look at, now we have, if we look at this sequence, F and comma I, it's a sequence in Y, right? In Y. And Y is compact by assumption. What does it mean? Like any compact metric space, any sequence in a compact metric space, there exists a convergent subsequence. So by that theorem, like the standard theorem, right? So if it's a sequence, we have a convergent subsequence. So we denote it by this. We can write down like this, comma I, comma J. This subsequence of subsequence of this, right? Subsequence of this and y sub 0 in Y such that this in Y, this F of this and Y sub 0 goes to 0, right? Because then and this is a subsequence of this and then convergent to some Y sub 0, right? So now we also, like, since G is continuous, and then this to the this is a sequence in Y and Y0, right? G is continuous. So now we have, if we apply G over this sequence, we apply this, goes to 0, right? Because it's continuous, so this goes to 0. And now what do we have? This is a subsequence of x sub n sub I, right? And then though both of them because of this. So from here, so one way we goes to the limit is G of f x 0. Now from here, the limit is g of y sub 0. And the limit is unique, right? So these two must be equal. But by assumption, g is also injective. That means these two values are equal. That means y0 must be f of x sub 0, right? So now if y0 is f of x0 from here, so from this, then we have f of x and ij, the subsequence, and f of x sub 0 under the matrix dy goes to 0, right? So this goes to 0, but x sub n sub I sub j is also a subsequence of this x sub I. And then for oi, the distance, the matrix in dy is greater than or equal to epsilon 0. And then now here we're saying this, the limit is 0, right? If you look at this, contradicts this, contradicts to what? To this. So which means like this assumption, this assumption is wrong, right? So f must be, f is continuous at x sub 0, right?